Right, so I decided, seeing as the last video was just stupendously long, and even after editing a lot of it out, it still ended up being about an hour. Took me, I'm not a video editor, and I don't know my editing software very well yet, so it took me a fair while of messing around to get it to go together. My laptop's a bit underpowered for video editing too, so yeah, it still ended up being an hour, and it's probably just about uploaded by now. It took 20 hours on my internet connection to upload the 7.5 gig or whatever it was of data that video encompasses. So yeah, just to save you and save me the tediousness, I decided to just jump ahead, and I'm going to go back to just doing this in sections. So I've actually cracked the circuit board holder out for doing the caps, because obviously got stuff on here and it's going to make it difficult to solder, and the caps are all different heights, so it is, well, you've got to you have to, like, some of the caps will stay in like these ones, and ones like these little ones, because of the way the legs are, you just give them a little crimp and they'll stay in. You can solder one, and you can come and push it from behind, and obviously you can't hold the iron, the solder, and push it at the same time, so you just tack a joint in, then come and push it from behind, push the cap in, do the other one, reflow that one, job done. And some of the other ones you have to just put a blob of solder on the board, you just line the cap up again, melt the solder, push it through, it tacks it in place. You can then flow one joint, push the cap from behind and line it all up. So that is what I did. So all the caps are in. I did measure them first. I was toying with, these are some of the caps I've got, and these are the ones that came with it. If you look on the board, the silkscreen layout was actually designed for these slightly bigger caps, but these are just fatter, they're lower profile, they're exactly the same capacitance and voltage rating, so figured there was no point in that. Oh, should we do a slow zoom? Fast zoom is so unprofessional. Oh, look at that slow zoom. So yeah, so resistors are all in, caps are all in. No, I'm missing a couple of caps. I've got to put these ones in. I'm going to have a dig around for my parts pile, because these just look like some real old. I've got like a box of stuff that someone brought in the 80s. It was like a load of rack drawer things, and it's got this style of cap in it, and I haven't seen this style of cap for sale for a long time. These look old and battered. All the leads are corroded and oxidized. This is like some new old stock they've got from somewhere, so they're not going in it. So I'm going to find some caps and solder them in, solder the valve sockets in, and then we shall be back and trying to figure out the wiring, because I think that's the one that's going to be the most work. Now, when I build amplifiers, normally the longest bit of work is all the chassis work. I have to, with nothing more than a few basic tools, drill out, punch out, shape various holes and stuff in the chassis, and that takes a lot of time. A lot of time, makes a lot of mess, and when you're just trying to do it in your spare bedroom, every hole you drill, there's little bits of metal swarf everywhere, so it's hoover it all up onto the next one. It's a very, very slow task, very rewarding task, mind you. So the chassis for this is already done, and it's really weird, just the board's already done, just bang 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 everything in, how quickly it's got to this stage. So yeah, solder the sockets in, and then I shall be back to try and figure out how to do the wiring, because like all wiring, you can just connect the points together and current will flow, but there's the right way to do it, and there's an awful lot of wrong ways to do it. So we shall see if we can figure out the right way to do it. What you get with your Chinese amplifier kit? You get this. So yeah, just like that. It's got some Chinese writing on it, and it's a bundle of rather low grade multi-core wire. So We've got this long black piece. I'm going to guess that's that was probably intended to be heater wiring or something maybe. So we've got a long black piece. We've got some brown. Some brown. Some blue. A short length of blue, a longer length of blue and grey. And again, we've just basically got lots of bundles of these. So these ones are all wrapped together. So what have we got here? Some blacks. I'm going to say there's a high possibility maybe these. I don't have a bundle. I have any chance here of two brown. So the speakers, there's on the output transformers, like any half decent valve amp. Which way? The screen's backwards. Right, so 0, 4 and 8. So you'd imagine maybe, for instance, in this bundle it's got two blacks, so maybe that's the 2 zeros for the output transformers. 2 yellows, maybe that's the 4, and 2 blues, that's the 8. And they're going to have to go to the switch here, which comically enough, where have I just put the bloody thing? The impedance selector switch, when you, oh, got a loose circuit board in there. Let's just lift for that, shall we? So you look on the back of the amp and it says 4 and 8 ohm. The impedance selector switch says 240 and 110 volts. So yeah, I'll get some, I'll see if I can't scrape that off at least. Because that is rather confusing, isn't it? But there's no, the 0V terminals from the output transformers for the feedback loop to work have to connect both to, so the feedback line has to connect to this point here on the 8 ohm tapping, but the 0 volt one needs to connect to something, otherwise there's no circuit made and the feedback line's doing nothing. It's just a large antenna picking up internal noise in the chassis, unterminated at one end, perfect noise injector. So it needs to connect to 0V. So looking at the board, we can make an educated guess here that on, where are they? These connectors here, one is the high voltage to the transformer primary center tap, and P1 and P2 are the two anodes of these valves, and the same the other side. So that would make sense. The heater wiring, at least I know on these octal bases, these ones it's going to be on 7 and 2, and on the input valves it's going to be on 7 and 8. But again, you know, there's no solder pads, you're going to have to solder straight to the sockets by the looks of it, I guess. So there's one connection here that says ground. Now that connects to the main 0 volt line on the amplifier. It doesn't connect to a screw terminal down here, no. So that's going to be the earth from the power supply, you'd imagine. But I will directly, well, I'd like to directly earth the chassis. I think I might be able to. There's a, yeah, the 0V line runs past this point and the screws won't get it. So I'm going to directly earth the chassis, as you should do, but I want a 10 ohm and 100 nanofarad cap, a 100 nanofarad cap and a 10 ohm resistor paralleled on the earth line to this point. It just helps eliminate noise being injected into the circuit board. And I mean, that's no good for a feedback return because it needs to be a star point. You know, that's got all the current, everything else going through it. The feedback, the 0 volt point from the feedback, the best place to connect it would be right basically where this gets its 0 volt from. So, oh Christ, yeah, so it's coming through the, it's just a ball aching, isn't it? So normally you'd have, I'm trying to stop saying obviously so much. I realise in my videos I say obviously a lot, and you know, not everything is obvious. It might be obvious to some people, but I'm just trying to stop saying it. So normally your 0V point would be connected, say, for a resistor here to the main 0 volt, and your feedback line, say it was coming back to the cathode, would come through here, and then your 0V point would connect to here. So, however, all the 0V current for the valve is already going through the transformer, so the transformer is connecting to a 0V point. It's going to be the last 0V point along, because you need to eliminate all the current that's being drawn from the cathodes of the output valves and all these points where they're injecting current. Normally you would go for a signal follows earth technique on a valve amplifier. So I'll draw this out so hopefully you can see what's... So you'd normally have your signal line, say this was your main 0V, turn that around so my hand's not so much in the way of it. So if this was your main 0V coming in here, you'd have your cathodes on your output valves, say coming here, then you'd have your grid 1 resistors through your output valves going there. Obviously you'd have your bypass caps there. I said obviously there, didn't I? Have your bypass caps there, then maybe you'd have your, if it was multi-stage amp, you'd have like your long-tailed pair connection coming here, but on a more basic amp, say that had a concertina phase splitter, you'd have your resistor there for your lower half of your concertina phase splitter, and then you'd finally have your input stage cathode there, and your signal in would connect to this point. Signal follows earth, and then your feedback line, if it was going to the, so that was a resistor for the cathoded input valve, and that was a resistor there for your feedback line. So your feedback line from your output transformer would come across here, and the 0 volt connection for your output transformer would come back to just after the input connection on the 0 volt rail. Then your speakers would connect straight here. Your speaker current isn't going down this wire. But on this one, the 0 volt signal is already coming through the transformer. So the question is, where would be the optimum place to connect this part of a transformer? Let's go on the lower schematic. This part of the transformer to. We're already pulling all the current through there, so I'm going to have my speaker connected here. I want to bring this back. I'm going to see if I can't find where the input lead connects. Try and figure out on the board how they've earthed it, if it's a star earthing scheme or if it goes bus bar, and connect just here. And again, that's not speaker current. I'm not injecting the speaker current into here. If this was a transistor amplifier, your speakers, you've got your main grounding point, your speaker would be here, and then everything else on the amp comes along this way, because your speaker current is also travelling through your 0V rail. But on a valve amp, it's not. The speaker current is only coming from the output transformer here. This is just feedback current, and you need no other current on here. If there's any current from these being drawn here, it's going to develop a voltage on the feedback line, and you're going to get noise. So I need to have a look on the board and try to figure out where I want to connect this to, because there is nothing obvious on the board I can see in terms of where to connect it. And if they just think I'm going to, oh well, they've given me so just got a load of solder bolt-on solder tabs, crimp connectors, but there's only one point on the board marked ground, and there's no way I'm just randomly soldering all them together right at the start of the 0V rail on here and having all the current draw up here. So this is the 0 volt point for the input stage, so I want my feedback line to come in just here. That's what I want, and that's what I'm going to do. Yeah, look, here's where the input caps, just grounding on this capacitor is just here. So yeah, I want it to come in before, well, after that point electrically, but before this point. So just here, really, I think. So I'm going to scrape away some solder mask here, and my two 0V rails for the speaker are going to connect just here. Remember, that's not for the speaker, that's just for the feedback line. It just references the transformer to 0 volt. And as for all the other connections, I don't know why I've got so many round terminals. I've only need to make the one connection to the board for the mains earth, to reference the board to mains earth. I know. I'm going to need to some of these on here, aren't I, on these speaker connectors. So yeah, if it'll focus in, so they're going to need to go on the speaker connectors. So that's 4 of them. I've got a mains earth is going to be one of them. So yeah, and I'm going to guess they was obviously counting that maybe the other 2 would be the, yeah, look, there we go, they're the same size. 3, 4, so still 4 more. What they plan to do with them, I don't know. Maybe they figured I was going to just connect all the output transformer and mains earth ones all together in one big group on the back of the board, and possibly I've just got one spare because I can't see what else that would be for. Maybe for a chassis earth, yeah, because there isn't a direct connection to the chassis, so one's going to be for a chassis earth as well, somewhere most likely. So yeah, anyway, I've got a vague idea of what it is I wish to do, so now I need to crack on and go and do it. And I think I'm going to call that a video at this point, because I've done a bit of soldering, I've done a bit of thinking. It's getting on a bit late, so I think I'm going to upload this as a short video, and then the next one will be actually doing the wiring. So if you've watched this one again, especially after the horrendously long and droning on segment that was the last video, I will say, as always, thanks for watching and catch you next time.